Okay, moving on. Today we're going to work on that addition of fractions with uncommon denominators. We're just going to do addition today and subtraction tomorrow. So I'm going to try and go through this pretty slow, but a lot of the steps you've already been working on for the last couple lessons. So I think this will go really well for us. Oops, I see I'm missing my fraction bars here. I'm going to put them in real quick with my black marker. Okay, got it. So first problem we're going to do, we're only going to do two, one of them with modeling and one of them without. The first one is 4/7 plus 1/3, and these two fractions we're going to be adding together have uncommon or unlike denominators. That means that we can't just add 4 plus 1 is 5 and 7 plus 3 is 10. Oh, 5/10, that's equal to 1/2. Nope, we have to find a common denominator so that we can add these together. So the first step I like to do anyways, and you can decide if this is for you. I think it is way easier to organize these and to show my work and do my work if I write them vertically first. So we're adding, that means the order does not matter. But I'm just going to kind of rewrite this as 4/7 plus, oops, plus 1/3. Okay, now our goal, kind of our first step, we're going to have to find a common denominator between these two fractions, between the denominators of 3 and 7. And that number, we're not going to fill it in right now on those new fraction bars that I wrote, but we're going to use common multiples or the least common multiple to find that value. So over here, we're going to make our list of multiples of 7 and 3. And remember, when I go through and list these off and I'm going to say them out loud, I want you to be thinking about when, if we were doing this in our classroom, you would yell stop because you also hear a multiple of 3. Okay? Okay, so I'm going to start with 7. 7 times 1 is 7. 7 times 2 is 14. I'm just separating these with commas. So far, I know that both 7 and 14 are not divisible by 3. There's nothing you can multiply 3 by to get 7 or 14. Okay, next one. 7 times 3 is 21. 7 times 4 is 28. 7 times 5 is 35. Okay, I'm going to stop right there. I just did the first couple multiples of 7. So I'm going to start with my 3's now. 3 times 1 is 3. Remember, you're just skip counting by 3's. So 3, 6, 9, 12, 15, 18, 21. So far, do we have any of those that are in common? Ooh, I see one. Right here. Okay, so our least common multiple, or the number that they both share, the multiple that they both share, the smallest one they both share, is 21. So that means that our new denominator that we're going to turn these into is 21. We're going to use multiplication to do that. Now, you can use your list of multiples to help you with this if that fact fluency isn't quite there, pop it into your brain right away. So all I did was rewrite that 21 and 21 here and here as our new denominator. Once we turn our fractions into equivalent fractions with the denominator of 21, then we can add and subtract. I'm going to copy my addition sign here too, just so I don't get off track with that. I realize that I'm adding. Okay, let's start with 4/7. So what we're going to do is use multiplication to find a fraction that is equivalent to 4/7 with a denominator of 21. And we know we can do that because 21 is a multiple of 7. So I'm going to start at this bottom one. Now you might be thinking, you're going to be working backwards. You don't even have to think about division. Just think, what times 7 gets you to 21? Or you can look over here. 1, 2, 3. 3 times 7 is 21. Whatever you do to your denominator, you also need to do to your numerator. And 4 times 3 is 12. So this 4/7 is equivalent to 12 21st. Okay, you're going to do the same thing to 1/3. Think, what times 3 equals 21? And if you really need to look at your list, 1, 2, 3, 4, 5, 6, 7. So I need to multiply my numerator times 7 too. 1 times 7 is 7. Okay, now that I have this, two fractions with common denominators, the same denominator, now I can just add. And if you really feel the need to rewrite this to stay organized, you can. So you can do 12 21st plus 7 21st. And just like we practiced 2 days ago on Monday, you keep your denominator the same, 21st, and then you just add. 12 plus 7 is 19. Once you get to this part, what I would like you to think about is, can I further simplify this? So now, instead of thinking about multiples, think about factors. Are there any numbers that we can divide both 19 and 21 by? And the answer is no. Part of the reason why I know that answer is no is because 19 is a prime number that is only divisible by 1 in itself. So unless 21 is also divisible by 19, this is going to be our final answer. Equals 19 21st. Okay, we're only going to do 2 of these today, so this is the last problem. We're going to start this very much the same as we did our first problem. I am just going to rewrite these vertically because I think that is easier for me to show my work in creating equivalent fractions. So 1/4 plus 2/6. If you are really good at that fact fluency and you've been working on increasing your fact fluency all year, some of you will be able to find this multiple right away. Now, what I want you to think about, a lot of kids like to use the strategy of just multiplying 6 times 4 because they say, hey, Miss Brucker, if I multiply 6 times 4, yeah, I'm getting a multiple of both 4 and 6. And that is true. I'm not disagreeing with you, but that doesn't mean that it's the least common multiple. And that means that when you get to your end answer, you're going to have to do more division to simplify. So it is always easiest for you to make that list of multiples and think of the smallest number that they can both be multiplied into. So let's do that right here. I'm going to do 4 and 6. We're going to go through and list our multiples of 4 and 6. I'm going to do the first like 5 or 6 of each one of these, okay? So remember, this is just like skip counting. 4 times 1, 4 times 2, 4, 8, 12, 16, 20, 24, 28, 32. Okay, so I decided to go 8. Okay, now remember, when I go do a 6, and you guys can even practice this by typing these out, when I get to 6 and I see a multiple that is the same as one of our multiples of 4, you can stop because that's going to be your least common multiple. Okay, 6, 12. Oh, there it is right away. Stop. Okay, so that means that's going to be our new denominator. We're going to make equivalent fractions of 1/4 and 2/6 that are 12ths. Okay, now again, we're going to use multiplication to do this. I'm going to start with 1/4. And what times 4 gets me to 12? If I don't know that right away with fact fluency, I can look at this list. 1, 2, 3. Or you could think about division. 12 divided by 4 is 3. Same thing to your numerator. 1 times 3 is 3. Okay, and down here, 6 times what equals 12? And that's 6 times 1 and 2. Do the same thing to your numerator. 2 times 2 is 4. Now that I have these, I forgot my addition sign. Now that I have these two fractions that are equivalent to 1/4 and 2/6 with a denominator that is the same or common, now I can just add 4 plus 3 is 7, and the denominator of 12 stays the same. Here's our final answer, 7/12. Okay, now I drew some fraction models down here. There's a couple things that you can do when you are doing this. I'm going to start first by doing fourths. Okay, we're going to be adding 1/4 and 2/6. Okay, so I partitioned the first fraction bar into fourths, and the second one I did into sixths, and I'm going to just add these together. Now, once we turn those into 12ths, that is like us cutting a line. I'm going to try and use a different color. That is like us turning these 6ths into 12ths. So now do you see how I turned that into 4/12ths? That's the same as this equivalent fraction we made up here. And then that would be like us breaking this, our fourths, into 12ths, also breaking each one of these into thirds again. So now I have 3/12ths. And if I put this fraction bar over here, I'm going to try and do this pretty quick, into 12ths right away. Okay, I'm just going to add 3/12ths and 4/12ths. 3/12 and 4/12. Should be 7/12. I should have 5 left over. And I'm going to count that remainder, the leftover ones that are unshaded. 2, 3, 4, 5. Yep. And I hope you guys are noticing this when I do fraction modeling. They are not perfect by any means, and that is okay. It is just a visual way for your brain to see that making of equivalent fractions. The multiplication that we did here, times 2 and times 3, that's how I decided how many pieces to break each one of my sixths and my fourths up into. So you see the fourths I partitioned into 3 pieces using that yellow marker, and our 6 we only broke in half to make twelfths.